The third thing I want to talk about with quadratic functions, after we solved them about a month ago, after we graphed them yesterday, is just be able to work with this most important point again, the vertex. So the vertex is going to represent the minimum value of the lowest point of the parabola. If it is the lowest point of the parabola, that opens up. This is called a minimum value. And the most important part of this minimum value is not the x-coordinate, but the y-coordinate. So for instance, the minimum value of this is 2. And where the x-coordinate comes in on this is we just say that the minimum value is 2 at the point, or at 3. Okay. Now if the parabola opens down, like on this one, let me come over here a little ways. Okay. Then we have a max value. It is the top of the hill. Okay. So it's the highest point that you see on this graph. And so in this one, again, the max value is 2, because that's how tall it climbed up my y-axis. And it is at negative 1, 2, 3, 4, 5. I believe that's negative 6. So that's going to help us with some word problems tonight in homework. So Uncle Phil's Daycare Center has a 500-foot roll of fencing and a large field. He wants to construct a rectangular playground area. What are the dimensions of the largest such yard? What is the largest area he can make? He's wanting to make a rectangular field. First off, note that if he just makes it so it's a long, skinny field, that it's not going to have much area. So he's going to need to space out the two sides that make the length and the two sides that make the width. Okay? And that's where that 500 is going to come in. It is my perimeter. The formula for the perimeter of a rectangle is you just add together all 4 sides. So in this case, I'm going to have 500 feet of fence to put the 2L and the 2W2. Now, it's asking about area. Okay. So to find the area of a rectangle, that's just going to be my length times width. Now the problem with this, yesterday, we always had something as y equals ax squared plus bx plus c. The only thing on this right side were x's. Well here, on this one, I have an L and I have a W on the right side of the equation. I want to have an L or a W. So to fix this, I'm going to come over here and I'm going to solve this for either L or W. I don't know, I'm just going to choose L. It doesn't matter which one, I'm going to get the same answer. So I'm going to subtract 2W from both sides and then divide everything by 2. I get 250 minus W is equal to L. And so I'm going to come over here to my L and I am going to plug in 250 minus W in for some direct substitution there. Get rid of parentheses, do a little bit of rearranging, and I have what was known as my general form yesterday. Just instead of x's, I have w's. And so, as you saw in the last slide, these maximum and minimum values are going to occur at the vertices of these parabolas. So I want to find what the vertex is. So instead of x equals or h equals, I'm just going to call it w today. It's whatever this variable is over here. It's going to be negative b over 2a. So it still goes in order, a, b, and then c came out to be 0. b can be negative 250. A is negative 1. So that gives me 125. That tells me the width. So to find my length, I'm just going to bring this W equals 125 and plug it in right here. Well, that tells me the length as well. It would be 125 feet. So what are the dimensions? The dimensions would be 125 feet by 125 feet. So more specifically, Uncle Phil, yes, he's making a rectangle, but more specifically, he's going to be making a square that would have the most area. And to find out what the area would be, yes, I can just go ahead and just multiply these two together, 125 by 125. Or I could take this 125 and plug it in for both of these w's. Okay? Same way I found the second coordinate of my vertex yesterday. But if I take 125 and I multiply it by 125, however you can get down to the answer of the area being 15,625 square feet is going to work for me. Example 5. I want to be able to write something called a vomit comment. Oh, I wouldn't write that. I would definitely keep its namesake if I wrote that. All right. Anyway, it's NASA's reduced gravity KC-135A aircraft that performs parabolic flights to simulate weightlessness. If you click on this slideshow from Google Classroom, you will be able to see a video of what goes on. It's pretty crazy. You just have this plane that's flying over these parabolic shapes, just going up and then down and up and down, and people are flopping all over this airplane because it's simulating weightlessness and not having gravity. And so what they've done is they've given me an equation for one of these parabolas. I'm going to outline it in blue right here. So one of these parabolas, where a of x is the altitude and x is the horizontal distance. Again, it's asking for a maximum altitude. So I'm going to go find what that maximum altitude would be. So they've already given me an equation on this. That's going to make this problem just a tad bit easier. So if I do my negative b over 2a trick again, plug this into my calculator, it gives me 15,500 feet. But keep in mind, that's my x. And then x is the horizontal distance. So actually that 15,500 tells me how far into the trip I reach this maximum height. I want to find that maximum height. So I want to find the second coordinate of this vertex. I'm going to call it A. So the maximum height's going to be found if I take this 15,500 and plug it in for this x, and then plug it in for this x, and evaluate it. So I guess I should say A of 15,500. Definitely a calculator problem, and whenever I work this, I get 26,000 feet in the air doing these, going really fast over this roller coaster like path. Pretty scary. So this answers the question. You have two very similar answers right here. Just make sure you're finding the one that matches what answers the question. Here's the video of it. If I play it, it makes my video file too long. So let's wrap this up. I kind of want to make sure you know everything about these quadratics, how they all relate together with what we've done. Okay, so this slide does a great job of showing that. First up, it says it just wants me to find the x and y intercepts. A great overview of this. Well, remember yesterday we said whatever is in this last position right here in general form has to be the y-intercept. So this graph goes through the y-axis at 28. To find my x-intercept, so what I'm going to do is I'm going to plug 0 in for my y on my f of x and just solve. I can factor a 2 out, or you can think I can divide everything by 2. Either way is fine because I have an equation on this and I'm just dividing by a constant. So now all I have to do is think of 2 factors of 14 that add up to give me 9. That would be 7 and 2. So subtract 7 from both sides, I get -7. Subtract 2 from both sides, oops, x plus 2, sorry, equals 0. Subtract 2 from both sides, x equals -2. So this graph would go through the x-axis at -7, 0, -2, 0, and it would go through the y-axis at 0, 28. I'm not going to work too hard on this, being able to go back and factor right now. I want to focus on graphing, but I did want you to see this. If you want to pause the video and brush up on your factoring and solving for B and C, please do so, and then I'll have the answers up. Be careful on C. I got it. It was not factorable, so whenever I tried to plug it into the quadratic formula, I ended up with the square root of a negative. That's going to introduce i's into my answer, which makes my answers imaginary, which means that it will not cross the x-axis.